There's a place in space where light dies, where time stops, where the laws of physics themselves break down and become meaningless. Scientists have discovered that beyond the edge of our observable universe, something is pulling on our galaxies, something massive, something that shouldn't exist according to everything we know about reality. This discovery violates the fundamental principle that nothing can influence us from beyond the cosmic horizon. The evidence is undeniable. We are being dragged towards something we cannot see, cannot reach, and cannot understand. Right now, you exist inside a bubble, a cosmic bubble 93 billion light-years across. This is the observable universe, everything we can possibly see, measure, or detect. Beyond this bubble lies the great unknown. The edge of this bubble isn't a wall. It's not a barrier you could fly a spaceship toward and eventually reach. It's something far stranger. It's a boundary in time itself. When we look deep into space, we're actually looking backward through time. The light from distant galaxies has been traveling for billions of years to reach us. The farthest light we can see comes from just 380,000 years after the Big Bang, when the universe first became transparent. Before that moment, the universe was completely opaque, a blazing hot plasma where light couldn't travel freely. This creates an absolute barrier to observation. No telescope, no matter how powerful, will ever see beyond this wall of fire. Scientists have discovered something that challenges everything we thought we knew about cosmic isolation. In 2008, astronomers made a discovery that shouldn't be possible. Galaxy clusters throughout the observable universe are all moving in the same direction, not just moving randomly, but streaming toward a specific region of space at incredible speeds, 600 miles per second. All of them, regardless of where they are in the universe. This phenomenon has been named dark flow, and it violates one of the fundamental assumptions of cosmology. In a universe that should be uniform and isotropic, nothing should create such a massive, coordinated movement of matter. Something beyond our cosmic horizon is pulling on our universe, something so massive that its gravitational influence can reach across the boundary that should separate us from everything else. The most mind-bending explanation involves a concept that sounds like science fiction. Our universe might be just one bubble floating in an infinite ocean of other universes. According to eternal inflation theory, our Big Bang wasn't a unique event. It was just one bubble of space that stopped inflating while the rest of the cosmic landscape continued to expand exponentially. This creates an endless multiverse where new universe bubbles are constantly being born. These bubble universes can collide. When two universe bubbles crash into each other, the collision would leave permanent scars, circular patterns in the cosmic microwave background, temperature anomalies that shouldn't exist, gravitational effects that could explain dark flow. We might be living inside a universe that was shaped by a collision with another universe, a cosmic car crash that happened before the first stars were even born. In the constellation Eridanus, there's a patch of sky that's impossibly cold. The cosmic microwave background, which should be uniform across the entire sky, contains a region that's significantly colder than it should be. This cold spot covers an area roughly 10 degrees across. That's 20 times the width of the full moon. And it's colder than statistical predictions say it should ever be. The most conventional explanation involves a massive void in space, a region with far less matter than average. Detailed observations have ruled this out. The void isn't big enough or empty enough to explain the temperature difference. The cold spot might be a bruise left by another universe, a scar from when a neighboring bubble universe brushed against ours billions of years ago. We could be looking at direct evidence of another reality, a universe with potentially different laws of physics, different particles, different constants of nature, a reality that briefly touched ours and left its mark forever. Gravity is the weakest force in our universe. It's so weak that you can defeat the gravitational pull of the entire Earth just by jumping. Electromagnetic forces in a tiny magnet can lift a paperclip against gravity from the entire planet. This weakness has puzzled physicists for decades. Why is gravity so pathetically feeble compared to the other fundamental forces? Gravity isn't confined to our universe. While electromagnetic forces and nuclear forces are trapped within our three-dimensional space, gravity might leak into higher dimensions we cannot see or access. Most of gravity's strength is diluted across dimensions we don't even know exist. We only experience a tiny fraction of gravity's true power because most of it is bleeding into realms beyond our perception. Massive objects in other universes or higher dimensions could exert gravitational influence on our reality. Their pull would be subtle but detectable across cosmic scales. This could explain dark flow. Massive structures beyond our universe, invisible and unreachable, might be dragging our entire cosmic neighborhood through space. Everything you think is real might actually be a projection. Our three-dimensional universe, with all its galaxies and stars and planets, could actually be information encoded on a two-dimensional surface. This is called the holographic principle, and it's one of the most serious theories in modern physics. The idea emerged from studying black holes. Scientists discovered that all the information that falls into a black hole is actually stored on its two-dimensional surface, not in its three-dimensional interior. The interior appears three-dimensional to us, yet it's actually a holographic projection of information on the boundary. Some physicists believe our entire universe works the same way. Everything we experience in three dimensions might actually be information encoded on the cosmic horizon, the boundary of our observable universe. The edge of the universe isn't just a limit to observation. It's the screen on which our reality is projected. What lies beyond that screen might be the computational substrate that's running our universe like a simulation. Asking what's beyond the edge of the universe is like asking what's beyond the screen of a computer monitor. The answer isn't more screen, it's the hardware running the program. Quantum mechanics tells us that particles can do something impossible. They can tunnel through barriers that classical physics says they can never cross. An electron can suddenly appear on the other side of a wall without ever passing through it. Quantum tunneling is how the sun produces energy. It's how radioactive decay works. It's a fundamental feature of reality at the smallest scales. Quantum tunneling might work at cosmic scales too. Some physicists believe that our entire universe might be metastable. We exist in what's called a false vacuum, a state that appears stable but could suddenly tunnel to a lower energy state. If this happened, a bubble of true vacuum would expand at the speed of light, rewriting the laws of physics as it goes. Everything inside this bubble would be transformed. Matter as we know it would cease to exist. The fundamental constants would change. Even the number of dimensions might be different. This transition would be completely unpredictable. There would be no warning. One moment you'd be reading this, and the next moment reality itself would be rewritten. This bubble of new physics would expand outward at light speed, converting our universe into something entirely alien. We would never see it coming. The edge of the universe isn't really an edge in space. It's an edge in time. Beyond this boundary lies not more space, but a different relationship with time itself. When we look at the cosmic microwave background, we're seeing the universe as it was 380,000 years after the Big Bang. Before this moment, the universe was opaque to light. It wasn't empty. It was filled with matter and energy, undergoing processes we can barely imagine. Some cosmologists believe that before the Big Bang, time itself might have flowed differently, or that time emerged gradually from something more fundamental. In models like the Big Bounce, our universe might be one cycle in an eternal series of expansions and contractions. Beyond the edge of our observable universe lies the death of our previous universe, the compressed remains of a cosmos that existed before ours, waiting to be reborn in the next cosmic cycle. The edge of the universe is both an end and a beginning, a boundary between one chapter of cosmic evolution and the next. Quantum mechanics tells us that observation changes reality. The act of measuring a quantum system forces it to choose a specific state from a range of possibilities. This has been verified in countless experiments. This principle might apply to the universe itself. Some interpretations of quantum cosmology suggest that the universe only becomes real when it's observed. The cosmic horizon isn't just a limit to what we can see, but a limit to what exists. In this model, the unobservable universe doesn't exist in any meaningful sense until we find a way to observe it. Reality extends only as far as consciousness can reach. Beyond that lies not more universe, but pure possibility. Conscious observers like us aren't just studying the universe. We're actually creating it through the act of observation. The edge of the universe would then be the edge of consciousness itself. As our technology improves and we can observe farther into space, we're not discovering a pre-existing reality. We're literally bringing new regions of the universe into existence. In an infinite universe, every possible arrangement of matter must eventually repeat. The exact configuration of atoms that makes up you, reading this right now, would occur infinite times throughout infinite space. There would be infinite copies of Earth, infinite copies of our galaxy, infinite copies of our entire observable universe. Some would be identical down to the quantum level. Others would differ by a single particle's position. Beyond the edge of our observable universe might lie another observable universe exactly like ours. And beyond that, another. An infinite hall of mirrors where every possible variation of reality plays out simultaneously. The edge of the universe isn't a boundary. It's a transition zone between one cosmic story and all possible cosmic stories. What lies beyond the edge of the universe? The answer depends on which of these mind-bending possibilities is correct. It might be other universes in an infinite multiverse. It might be higher dimensions leaking gravity into our reality. It might be the computational substrate running our universe as a simulation. It might be pure possibility waiting to be observed into existence. Or it might be something so alien to our understanding that we don't even have words to describe it. The edge of our observable universe isn't empty. It's not a void. It's a boundary that separates the known from the unknowable, the real from the possible, the observed from the unobserved. That boundary is trying to tell us something. Through dark flow, through the cold spot, through the weakness of gravity, through the holographic principle, reality is whispering hints about what lies beyond. We exist at the center of a cosmic mystery so vast that it encompasses everything we can ever hope to know. That mystery is aware of us. It's influencing us. It's shaping our cosmic neighborhood in ways we're only beginning to understand. The edge of the universe isn't the end of the story. It's where the real story begins.